So our goal here is to find the least common denominator of all four of the small fractions and then use it cleverly to change this problem from one that involves four fractions to one that involves four numbers. And those numbers will be much easier to work with. It's almost like a little bit of magic. So let's write down the four small denominators. So we've got a 2, a 3, a 4, and a 6. 2, a 3, a 4 is 2 times 2, a 6 is 2 times 3. So now let's build the least common denominator. It has to be able to cancel all four of these separately. So it's got to have a couple of 2's in it to cancel this, and it's got to have a 3 in it to cancel these. And so this, 2 times 2 times 3, if you put it here, 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 and here, it will have enough parts to cancel both of those, this one, and this one. And so that's it. That's 12. Some of you probably knew just by looking that the least common denominator of 2, 3, 4, and 6 is 12. Now what we're going to do with the 12 is we're going to multiply the top by 12, and we're going to multiply the bottom by 12. And it would be nice if you could do this in your head. So let's try it in our head, see what happens. 12 times a half. You could either do 12 times a half this way and slowly, gradually discover that it's 6, or you could just do a half of 12 and think of what's half of 12, and it's 6. A third of 12. Can you see the 3 and the 12 canceling to a 4? So a third of 12 is 4. If you can do these in your head, it's really a pretty good thing. 12 times 1/4. Let's say you can't do it in your head. You don't want to. Well, then you come over here and 4 goes into this once and 4 goes into this 3 times, and you find out that it's 3. A fourth of 12 is 3 minus a sixth of 12 is 2. And now you have 10 over 1, because 6 plus 4 is 10. 3 take away 2 is 1. So we turned it from a fraction problem that looks kind of scary to most normal human beings to an arithmetic problem which is not very scary at all. It's just 10. It gives us two ways to do this. I'm going to show you the way that we used in the previous problem, problem 9. The least common denominator is something that can cancel this x minus 1 right here, and can also cancel this x minus 3 right here. Those are the two denominators. Well, it's this times this. So we're going to multiply the top by that and the bottom by that. And it looks kind of like this is going to be a difficult problem. But we're going to find out that it's not really too difficult. Here, when we multiply by these two things, this cancels this, and we're left on top with x plus 2 times x minus 3. And on the bottom, this is canceled with this, and we're left with x plus 4 times x minus 1, and nothing cancels. And we could multiply this out, but I don't think we need to. I think we're done. Here are our four denominators. We need an x in our least common denominator, and we need a 2 times a 3. So our least common denominator is 6x. So we're going to clear all four of these fractions by cleverly multiplying through by 6x. Now, the last time we did this, I kind of had you do it in your head, sort of. Now let's say that we don't want to do it in our head. It's too hard. We can distribute this 6x through the top by just multiplying a copy of it here, and multiplying a copy here, and multiplying by a copy here, and multiplying by a copy here. So we literally distribute it through. These 6's would cancel and be left with x squared. These x's would cancel and be left with minus 18. The 6 over the 3 cancels to 2, and we're left with 2x. The x's cancel, and we're left with plus 6. Now all we have to know is whether this reduces any at all. So the top is factored as far as we know. The bottom at 2 can come out. We have 2 times x plus 3, but there's nothing else that can happen. So this is a good answer, and so is this. They're both fine. These are the four denominators, so the least common denominator is something that, if it's put on top of each one of these four, can cancel every single one of them separately. Well, since they're all built out of c's, this is the one that has the most. We need a c cubed for our least common denominator. Now, how are we going to use that? We're going to multiply the top and the bottom of this fraction by the same thing. And so we're keeping an equal fraction, but it will get rid of the common denominators. Now, the last time I distributed it through and did it with, ink, so to speak. But here I'm just going to try it by thinking about it. This c cubed and this c squared, when we distribute this, two of these cancel two of these, and we're left with just a 7c on the top. C, if you can do that in your head. Here, when this gets distributed here, this c on the bottom cancels one of the three, and we're left with two of them on top. Here, when this comes across, this one cancels one of the three, and we're left with 6c squared. And then, I don't know why I put a plus sign, because it's pretty clearly minus. This c cubed cancels this c cubed when we distribute here, and we're left with just a 3. Now, technically, before we decide if this is our answer or not, technically we should factor. So I will do that, even though I'm not very excited about it, because I don't think anything is going to cancel. And sure enough, there's no c on the bottom, there's no 3 on the top, there's no 7 plus 4c, there's just nothing that cancels. So this is an acceptable answer, but so is this.